Hello everyone, and welcome to Damper Tech, where we specialize in HVAC. We do everything DIY, and today we have a follow-up service call for a inline duct furnace. Thank you to everyone tuning to Damper Tech. We have quite an interesting inline duct furnace here. So further down this duct outside is your supply fan, which also is a fresh air intake. So it pulls air from outside, fresh air, and brings it in through. And this is serving a commercial kitchen. Got a couple things over here. Let's see what we got. The only thing is this thing is bothering me. I really hate this thing, this little Maxi Troll Selectra. If you guys see this, leave a comment below. And this is some kind of sensor in here. Got some smoke alarms, red cables, got fire relays coming in here. So in my last visit, this thing didn't work at all. What I found was the transformer went bad. So what I did is I replaced it. The old transformer, just basically you lost the 24-volt circuit. It somehow, something intermittently tripped here and shut this whole thing down. So because this thing shut down, and it shorted out, we actually burned out the transformer. So what I did was I put on a transformer with a reset. Got a little breaker right here, and it runs for 2 weeks and then randomly trips. You reset that breaker and it comes back on. So if something's going on here with the 24-volt controls, I spoke with the engineer and he wanted to do a couple of change outs. Right here, this is your ignition control, and inside this box here we have a sequencer. Those both run on 24 volts. A couple parts came in, so we're gonna go ahead and start that. Also got a new spark igniter wire assembly. Actually, it comes with your pilot right here. This is your pilot tube. So you got your pilot and your whole ignition system there. For now, because it's hard to get to at the moment, I am gonna be changing our ignition control and sequencer. So here's our ignition control, intermittent pilot ignition, 24 volts, and a 24 volt heat sequencer. Maybe something is going on here intermittently and shorting out that transformer low voltage side, 24 volts. Let's throw that in there while I'm here. I got a little bit of time, and yeah, that's what we're gonna make of this service call. Whenever there's an intermittent issue where like things ground out, it's very hard to catch, because if there really truly was an issue, when you try to reset the 24 volts, it wouldn't reset. There'll be a problem, you could find it and fix it. But for the fact that you can reset it and everything's back to normal, that's a little strange. It's something with the 24 volt circuit. I know the ignition controls 24 volts and the heat sequencer. That could be a thing. 24 volts does run through this air pressure switch and this gas valve as well, but this is kind of the brains of the system. And they do have this Maxi Troll Selectra switch where it's a modulating gas valve here. Now this is the regular gas valve with the pilot tubing, but this is like a gas modulator, so it like opens and closes the gas flow depending on like what temperature you want to keep it at. Anyways, let's shut this thing off. The LED lights went away. That's good. And let's start looking into this. Let's pull off each wire, put it on our new control, and then we can mount it. So here's your spark. I will just get rid of that. Can't go wrong there. If you do, you're in the wrong business. All right, so we should be using the same terminals, to be honest with you. TR, if it's a little loose, what I do is kind of crimp this down a little bit, so I want a nice tight connection. Blow that out. It's gonna be TR is really our thermostat ground. This wire ground burner, gonna have to leave that on the side for now, because it's actually connected to the what's mounting this thing. All right, TH right here. Just like to crimp them down a little bit. So we got a nice, good connection. TH. Okay. PV. So PV is gonna be your pilot valve. It's what, there's two little solenoid valves in this gas valve. So MV would get energized and send gas through the pilot tubing. It would light. Once we prove there's a flame, then PV pilot valve gets de-energized, and the MV, which is your main valve, which is the main flow of gas, opens, and that's how you got heat. So do that. PV. Okay. MV slash PV, which is basically the ground. Let's see, what does this one say? Same thing, MVPV. Yeah. You always need to complete a circuit somehow. Then MV, main valve. Okay. Drop that down a little. Here we go. These connections don't look too bad. Oops, got 1/4-inch screws there. All this stuff is over 10 years old. You might want to make some adjustments here. That's one screw. Let's be careful with this one. It's holding the ground here. You want real good ground, nice clean ground when you're working on any kind of heating system that uses natural gas. Huh. Doesn't want to go through? Stop playing. Might need to get a flathead in there. Yep, I'm not gonna go through. Let's get a flathead. Alright. On the 1/4-inch screw, because my chuck is a little bit bulky, you also have an option to use a flathead. So that's what we're gonna do. There you go. Make sure, because it's going through plastic, and then basically it's using the screw as the ground. I kind of don't like that, to be honest with you. I might put that behind here for a better ground. You want a good ground, not on the plastic. So I'm gonna put this behind this here, and then put the screw. So this unit's made by, it says Airedale, and I called the number, and Airedale is actually like a line of Modine, and Modine is a very, very well-known heating company, and I don't know, they might do other things, but I know them for their heating products. So let's see, might even want to sand down that connection. Want a nice clean ground, nice clean ground. Sand down the metal, and may even put a new stake on connector there, or you know, just sand that down as well. So let's put this side in. There we go. Then we can just let that hold so I can give this thing its final tight down. But we don't have a problem with flame. Our problem is losing this 24 volts randomly at random times. So for the fact we're getting a new ignition control is already a nice new thing. Whatever goes through that 24 volt circuit, man, just get rid of that thing. This thing is so old, lucky they're not getting a new unit. Might as well rebuild the controls. That's that. This thing here. Want a nice, good, tight connection. There you go. There's our ignition control. Alright, let's open this up. Remember, this thing was hard to take off last time. Maybe it's going to be easier now. Nope. Oh, there we go. It's a little bit bunched up in here. We got a heat sequencer here. We got to be careful. Put everything back in its place. Here's our heat sequencing relay. And it's tucked in back here, if you can even see it. I mean, it's a whole mess and a half here. Oh man, but it's what's inside there. So you gotta figure that out. What's cool about this unit here is that for common parts, it actually gives you the part number. That's honestly amazing. And that's where I got this ignition control and all that stuff. And this, so that's just a beautiful thing right there. Let's see, what's the best way about going about this? Honestly, let's make some space by removing some of these wires from here. This thing is a mess and a half. So I'll try to make some space as much as I can with what I can. Okay. Maybe get a pair of snips and open this up right here. Start moving things out of my way. And like that, I have space to work and do what I have to do properly. Okay. Get all this stuff out the way. Actually, this is actually okay. Right here. All these extra things, just get it out. Now we can work a little clearer. Is that really only, oh, there's one screw holding, but there's also like a little tap in. So right here, it's like this little holder thing. So it goes in, and then it just holds with one screw. Cool. All right, so I'm gonna go for that screw. I'm gonna go for that screw. Try to make some space in here and see what I could do. Having trouble. So this goes like this. Let's start pulling a couple things out and putting them where they go. And let's once again, this connection crimped. Very poorly crimped, you know what? That's not cool. Very, very poorly crimped. Want to make sure you got good connections. Make sure we don't have any issues. You know, loose connections, bring up the amps. Anything could trip. So, let's actually crimp this thing. Ooh, this thing is freaking crusty. That's definitely a better connection. So this goes like this. Let's get this where it goes. That's nice and tight. All right. So I'm just showing you guys the live process of like how I would go about this without writing everything down and labeling it, which is always still a good idea. So that would be the top. Remember what side is what. Now this can come out. Okay. I would just have to set this all up. So this two go on the bottom, in the back. Use needle nose and pull off with the connector. Don't pull the wire because you're gonna mess up your connection. Is there space anywhere? I'd rather put it on there and then later if I need to redo it, I'll redo it. But like that, I get this control off and it's proper. Might need to redo it, but let me just do it like this so at least I can get things in place. Sometimes dealing with stuff like this is tricky. Tighten all the connections after. Right here, that's that. And can I get this out of my way now with the wire still connected? Yes, I can. That's that. So now, do I have space to do anything? That's the bottom. Let's get this. Oh, come on. Let me get that tucked in. Can I? Come on. See anything else? There we go. Got that in. Let's lock the screw down. That's what I'm talking about. Remember to crimp down on all the connections. I thought I was gonna take it off, so I didn't do 2 of them, but best believe I will. Make sure you got all. You know, these weren't actually crimped. These weren't actually crimped. It was just like tightened down, but a crimping tool wasn't used. I have a crimping tool on here. Let's just do that. Give a little extra security there. And basically I'm taking one wire off, putting one pot wire on, one by one. That's it. That's how you do it. Nice tight connection. And I got 2 more to go. Make sure they're all tight. The connector and everything is crimped on. And we're good to go. These two go in the back. All right. Just taking off some connection I took off earlier. It looks like I gotta actually crimp these. They just kind of squeeze them together. That ain't cool. So crimp with the stake on, solderless connector, and press down on the connector itself, so we got a nice tight connection. Okay. Man, it's a little hard to get in now. Come on. Tell me it's too tight now. Don't do this to me. Okay, we got it. All right, so just gonna keep going. There you have it, guys. Another control component in. Everything's looking nice and clean. I want to look at these to see if those are crimped. Make sure we got all good connections here. It's very, very important for the proper operation, especially when you got like intermittent shorting issues. All right, guys, I was just putting some like tie wraps and everything to make things neat. Look at this. Oh man, it's freaking spark wire, man. This is the spark wire. I'm trying to wire nut it. Ugh, that might be a bad idea. This thing looks roasted. Don't tell me I really gotta change this thing now. Oh gosh. Guys, I seriously hate to do this, but I have to go to a different job. I actually came here for a meeting, but unfortunately the guy didn't show because they scheduled for Wednesday. Today's Monday, but I was told Monday I'm here. So listen, while I was here, I figured let me at least get something done. If I really have to, I'm gonna have to change that. But could that have been what was shorting things out? It's not 24 volts coming out of that spark wire. In some cases it's like 10,000 volts. Actually, you guys do some research on that. It's pretty interesting. But it is a 24 volt control. What if this thing was tripping because of this bad wire, and that's what was shorting out the 24 volt side of this transformer? Who knows? I don't know. But that's put back together. Flip this on. Got a light there. So what's gonna happen is there's a fan running here, as long as that's good. Right here. Then this motor right here, this is an inducer motor, is getting all the exhaust gases out. Once this is on, then there's an air switch here to prove this is running. That's gonna go. And well, of course the thermostat calls first, then the sequence starts. Once this closes, then it should actually energize. Right there, got a green light on our ignition control. PV starts. We have 24 volts going to PV. Oh, that was quick. All right, we got a flame. So what happens is PV gets 24 volts, comes back down to PV, MVPV, completes the circuit. So we're energizing the gas valve to send gas through the pilot tube. Once the pilot, once that goes through, the spark igniter goes at the same time. You hear like a little buzzing sound, and it ignites the pilot gas. Once that pilot gas is proven to be lit, we de-energize PV, and then we energize MV, which is the main valve, and another solenoid opens here and sends the main gas, and that's when you got that flame like that. But honestly, this piece right here is going to be changed next. We're going to have to get inside here and actually do some maintenance on this system. So we have to open up this cover inside here. You can't see anything, but inside there is where it's at. And unfortunately, there's some screws all the way on the edge that you can barely get your finger in. That needs to come down to bring down this whole tubing, because we're probably not going to get to it. Check that out. Got a flame. All right, that is a beautiful thing right there. Oh, thank God that wire. It is what it is for now. And let's see what happens. We're going to come back and change this whole spark igniter assembly, pilot tubing, all that good stuff. Yep. It's the pilot replace kit. Here's the main burner pilot assembly. So over here, let's see if we can take a look at this. It comes with a new pilot tubing, which is that. So you gotta change the pilot tube. You gotta connect it to the gas valve over there. So of course you're gonna have to close your gas, but if it's not energized, it's not really going to be passing gas through there. But anyways, so you're going to have to change this piece here. This is the pilot assembly, and this piece here with the spark igniter is actually the wires connected in there. It's not like something you could change. So from there, you will connect that through here to your ignition control there, that orange wire, and you're going to have to mount it inside there. It's a little tricky, but just so you guys got an idea of like what this looks like. Everything is looking good for now. We're gonna wrap this up for here. We got a new ignition control. It's nice and clean. I redid the ground to where the wire is behind the thing, because it doesn't just sit on plastic. It's like direct metal to metal, not just through the screw. That screw gets loose, you're gonna have problems. Anyways, that with a new sequencer, we're in pretty good shape. And I guess it's good that I was trying to fix up this wiring to try to make it look a little neater, because that thing was like triggering on my OCD. It looks pretty ugly here. They actually mentioned that they used to play around with this wire, and that's how they would get it to start. That's why they said this piece of tape is here. They used to tape it in a certain way for it to work. So it must have had a bad connection for a long time. Either way, that's all going to be replaced. But for now, looks like I can go to my next job. They got heat. We're gonna wrap it up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.